Hello and welcome back. In this video, we will be doing corner simulations on our inverter. Remember our inverter. So a corner is just like a region on the silicone that varies from what we would expect from what is typical. And we can simulate those to ensure that no matter where our chip is placed on the silicone, we can kind of predict what's happening and ensure our design will work on those corners. So what I've done and what every fab will have is a giant list of corner files. And maybe I can show them to you quickly here. And these are just descriptions of all of the different areas of the chip and how certain components will behave. So COR is just short for corner. For basic MOS capacitance, resistors, RF MOSFETs, and a whole bunch of stuff. And they model these in Spectre, in basically a Spectre netlist. What we want to do is we're using just standard MOSFETs. And so we want to simulate on the slowest corner, the fastest corner, and a typical corner. Hit OK. Go back to our, we don't need this anymore. Go back to our simulation. We don't need this either. And if you go to corners, you will see our corners. We can then rerun the simulation, and our output will now show our varying corners. Now, obviously, the simulation takes a little bit longer to run because it's running 4 simulations opposed to just 1. But when it finishes, you will see how the inverter varies in its operation. So it has finished, and we can take a look here. And if we zoom in, you can see the different corners. Slow, slow, typical, and fast. And if we really zoom in, it becomes more clear how they vary. And it is useful for larger designs where there is more than just 2 transistors. You're going to want to ensure that it's functional on all areas of the chip. But that is how we run corner simulations. In the next video, we are going to optimize our inverter or we're actually going to go over the calculator first so that we can extract parameters for optimization.